As you saw in the earlier section of this module, AWS offers many compute options. For example, Amazon EC2 provides virtual machines. As another example, we discussed before the use of Amazon Elastic Container Service and Amazon Elastic Kubernetes Service, which are a container-based compute services. However, in this section, we are going to focus mainly on the third approach, which is referred to as a serverless computing. AWS Lambda is an event-driven serverless compute service. Lambda enables you to run code without provisioning or managing servers. You can create a Lambda function, which is the AWS resource that contains your code. Then that function will be triggered by any event you choose, either on a scheduled base in a response to an event, or a code you only run when it is triggered. You pay only for the compute time you consume, and you are not charged when your code is not running. A good example of AWS Lambda, guys, is the use of Alexa. The wake-up call when we say, hey Alexa, is going to trigger a code, and that code is basically a Lambda function. With Lambda, you can use different type of language and tools and framework. Lambda supports multiple programming language, including Java, Go, PowerShell, Node.js, C#, Python, and Ruby. Your code can use any library, either native or third-party. Lambda completely automates the administration. It is a fully automated and managed service. It manages all the infrastructure to run your code on highly available, fault-tolerant infrastructure, which enables you to focus on building differentiated backend service. Lambda seamlessly deploys your code, does all the administration, maintenance, security patches, and provides built-in logging and monitoring through Amazon CloudWatch. Lambda provides built-in fault tolerance. You can orchestrate multiple Lambda functions for complex or long-running tasks by building workflow with AWS step function. Consider now an example. Let's say you want to reduce the cost of your Amazon EC2 usage. You decide that you want to stop instances at a predefined time, for example, at night when no one is accessing them. And then you want to start the instance back up in the morning before the work starts. In this situation, you could configure an AWS Lambda and Amazon CloudWatch event to help you to accomplish these functionality. And this is what will happen. A CloudWatch event is scheduled to run a Lambda function to stop your EC2 instance at, for example, 22 GMT at midnight, and the Lambda function is triggered and runs with the IAM role that gives the function permission to stop the EC2 instances. The EC2 instances enter the stopped state. Later at, for example, 5 a.m. GMT, a CloudWatch event is scheduled to run a Lambda function to start the EC2 instances, and the Lambda function is triggered and runs with the IAM role that gives its permission to start the EC2 instances. The EC2 instances enter the running state. And this is how we do it in the console. So the first thing we want to do is to go to the AWS Management Console. You can see there is a serverless application and there is Lambda. So once we select Lambda, we want to create a function. We need to give this function a name, and that function will be a Python 3.8. Then what we need to do is to configure the function of the AWS Lambda. So in the first task, we are going to configure, after we create the Lambda function, we are going to configure a trigger for that Lambda function. So let us create a function. Now we need to select an existing role. Now if you are using this from a root account, you will be able to create a predefined role. You don't need to select the role that I have here in my lab setup. And now we want to configure the trigger. The trigger is going to link a CloudWatch event using the event bridge with AWS Lambda. So let us select Event Bridge. And now we want to make sure that we are going to select to create a new role because we don't have any role predefined. The next thing is we are going to put and to create a new rule, and that rule every minute where we will schedule the expression, and the expression rate will be 1 minute. So this is more realistic, a schedule-based stopinator Lambda function, which will be triggered by using cron expression instead of a rate expression. For the purpose of this demo, we can use a rate expression to ensure that the Lambda function will be triggered soon enough that you can see the result. We don't need to wait for a long time. Now let us go to the Lambda function, to the code tab, and in the code tab, we delete the existing one, and we will put the code for the demo. I'm going to make this code available for you so you can download and use it. In this code, we need to replace two things. We have to replace the region code, and we have to replace the instance ID. And then we need to go back to the EC2 instance in US East North Virginia. And from there, we want to copy the instance ID and we paste it inside the square bracket inside our Python code in the Lambda function. And then we press deploy. And once we deploy the function, we are going to wait for a few minutes to see the result. Now, you could also go to the Lambda and test your code using the test functionality that you have in the Lambda console. And you could also go to the monitoring tab. And from the monitoring tab, you will be able, if there is any error in your code, or if there is any error in the invocation of the function. Now, as you can see now, the function has been invoked for one time in the monitoring tab, and we want to go now to the AWS console to verify that our EC2 is stopped by the Lambda function. You could also create a test event, and these are very useful if you have a very complex code you want to test before deploying to make sure that everything is working in a proper way. So that's all about Lambda function, guys. Thank you for seeing this video and see you in the next one.